Now, in the last few days, you've learned about triangle congruence and the criteria that it takes for two things to be congruent. And then yesterday, we learned about triangle similarity and the criteria it takes to make two triangles or two polygons similar. So today, we're going to really outline the differences between similarity and congruence. So today we went through a few text-based questions delineating the difference between similar figures and congruent figures. So I'm just going to go through this quickly since we went through it today in class in depth. But basically, when are two figures similar? When are they congruent? Two things are similar when they have the same shape, but they are a different size. Two things are congruent when they are the same size and the same shape. When we say shape, we're referring to the angles. So corresponding angles are going to be congruent, and yet sides are going to be different. Okay? Number 2. What is the difference between similar figures and congruent figures? Draw two similar and two congruent figures to show the difference. Okay, so a similar figure, we're going to have a small triangle here and then a larger one here. This is going to be the child of the parent, which is the bigger one. And then for congruent triangles, think of them as twins. They're going to be identical. Here, I'm just going to make them a little bigger, okay? Okay, now this next one says, what is the symbol for similar figures and for congruent figures? The symbol for similar figures is this, and the symbol for congruent figures is this. Now, if we wanted to use this symbol in a statement, let's say this is triangle ABC, this is DEF, okay? We would write triangle ABC is similar to triangle DEF. And then up here with our congruent triangles, we would write triangle ABC is congruent to triangle DEF. Okay? How are the sides in similar figures? How are the sides? How are they in congruent figures? Why? In similar figures, the sides are proportional, right? So in similar figures, the proportion of the ratio or proportion of side AB to DE is equal to the ratio of BC to EF, which is equal to the ratio of AC to DF. And we know this all because of the similarity statement, right? AB and DE, BC and DE, and then AC and DF. Okay, and that's exactly what we had down here. Okay? In congruent figures, all of the sides are equal, right? So side AB, I'm looking at this figure up here, right? Side AB would be congruent to side DE. We could also get this not only from the figure, but also from the statement, right? AB is congruent to DE. We have BC is congruent to EF. BC is congruent to EF. And then we have AC is congruent to DF. Okay? All right. Number 5, how are the angles in similar figures? This should be angles. How are the angles in congruent figures? Remember, in similar figures, all of the angles are congruent. So angle A, we look at the similarity statement to find our corresponding angles. Angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. In congruent figures, same deal. I'm using the similarity statement to find corresponding angles. Angle A is congruent to angle D, angle B is congruent to angle E, angle C, sorry, let me move that back. Angle C is congruent to angle F. Okay. 6, what is the similarity statement? What is the congruence statement? Similarity statement, it looks like this. ABC is similar to triangle DEF, and it gives us all that juicy info. It tells us what sides are corresponding, and it also tells us what angles are corresponding, okay? What is a congruent statement? Triangle ABC is congruent to triangle is congruent to triangle DEF. And same as the similarity statement, it's a juicy statement. It tells us what sides are congruent, and it tells us what angles are corresponding and congruent. Okay? What is enough for two triangles to be similar? What is enough for triangles to be congruent? So for two triangles to be similar, we have two postulates, angle theorem, or side proportional. So this is saying that if two angles are equal, then we know it's a similar triangle. If all three sides are proportional, then we know they're similar triangles. And remember, for congruent triangles, we had the four postulates, right? Side, angle, side, angle, side, angle, side, angle. Okay? So these are for congruent triangles to prove that they are congruent, and these are for similar triangles to prove that they are congruent. Okay? Let's do an example problem from today. The pair of polygons is similar. Write a similarity statement, find x, bc, ps, and the scale factor. Okay, so we have to, 1, write a similarity statement. 2, find x, bc, and ps. And 3, find the scale factor. Okay? So, first let's write our similarity statement. We're going to go around the figure starting with the first angle, starting with angle A, and I'm going to go A to B, C to D. Is similar to, I'm going to start with the same angle over here. I'm going to start with angle P because it has one line just like angle A, right? And then I'm going to go over to the first right angle because that's what I did over here. Okay? Q, hold on, let's P, Q, and then I go to R, and then I go to S. Okay? So now I have my similarity statement. What if I wrote my similarity statement like this? Same thing. It doesn't matter where you start, it only matters how you continue, and that you continue in the correct order. Okay? So we have number 1 done. Great, we wrote our similarity statement. Now, we need to find x. X is right here. X is the side PQ. Okay? So remember, if we have similar figures, we can set up a ratio in order to find the missing side because all sides are proportional. So we can either use the similarity statement as our guide or we can look at the picture, right? I'm going to try looking at the picture since we already know how to find corresponding sides using the similarity statement. All right, so we always start with x, right? So x falls on the side between one angle and a right angle. So I'm going to look for the side in the first figure where this angle 1 and a right angle, and that is 3.2, okay? Now, I need to set up a ratio with another set of sides. Let's look at SR, this side here. It's between 2 and a right angle. So the side that's between 2 and a right angle up here is CD, which is 1.4. Okay? And now, I cross multiply. Hold on, let me just erase this. I cross multiply and I get 1.4x equals 2.24. Get x by itself. Okay. X is now 1.6. As soon as we get the info, we put it in the figure, right? Oh, that looks really messy. As soon as we get the info, we put it in the figure, right? Okay. So now let's find, we found X, now let's find BC. BC is right here, this side here, okay? So BC, I'm just going to name this Y now because I already used X up here and I don't want to get confused. So the new variable that I'm looking for is Y. And Y, the side between the two right angles, corresponds to this side on the other figure, which is 0.7, okay? And now let's use CD, which is the line between the right angle and the angle for 2. The right angle and the angle for 2 right here is 0.7, okay? So we have 1.4 corresponds to 0.7, right? Now we cross multiply, what do we get? 0.7y equals 0.98. Divide both sides by 0.7. Y equals 1.4. 1.4. Okay. Now we need to find P. We found BC. Now we need to find PS. PS is the line where that's between 2 and 1. That corresponds to this side over here. Yeah, she left already.
Where'd she go? What's wrong with her?
I don't know. I'm making the video for our class, though.
You're doing what?
I'm making the video for our class.
I wanted to check with you guys. I wanted to do the hour. What grades do you guys have?
Just 10th grade.
Just 10th grade? I'm trying to do the hour of code this week by having students kind of like, come in and teach the class. Do you guys think you can give me like an hour of your time with some of the students?
Oh, you'd have to ask Miss G. I don't know. Sorry.
Can you like leave
Fill
it
this
out here
out?
for her? No, just like leave it out for her. And then I can, like tomorrow morning I can check in with her and stuff.
Okay. Do you want a copy of our schedule on these days, or?
Well,
okay.
one of those days, if, for example, if she's got lessons for tomorrow or whatever, then, like whenever she can have guests over, she can write down the times.
Okay.
Thank you very much.
Yeah, sure. Okay, and let's see. Okay, so Z is PQ right here, and that corresponds, that's between one angle here and the right angle. So the angle between one and the right angle over here is 3.2. So we now have Z oops, sorry. Oh, wait, no. I'm sorry, here. Z is this side right here, okay? And that corresponds, it's between 2 and 1, right? So that's going to go to the side that's between 2 and 1 over here, which is 2.2. So Z is going to correspond to 2.2, okay? And then let's use SR, which corresponds to, oh no, let's use QR, which corresponds to Y. Okay? And we get Z is equal to 1.1. Okay? Z is equal to 1.1. Okay, so now we found all of the missing pieces of info, okay? I'm going to clean up my figure. Okay. All right. Now the third thing that we need to do is find the scale factor. So scale factor is just going to be the side divided by its corresponding side, okay? And order doesn't matter, which order that you choose, okay? Because look, if I choose to go from big figure to small figure, right, I'm going to do 1.4 divided by 1.1, and then, oh no, that's not the corresponding side. I'm going to do 1.4 divided by 0.7, and I'm going to get 2. But if I did from small to big, I would get 1.1 Z divided by 2.2, and I would get 1/2. So you can either go from big to small, or you can go from small to big. Your scale factor is going to change, but the problem will tell you which way it wants you to go. So it'll say A, B, C, D is similar to P, Q, R, S. Find the scale factor, in which case you'll know that you need to go from this one to this one. Okay? And last, actually we're not going to do this problem, okay?